Okay, so I'm going to go to share screen. So what I have started here that hopefully you've been able to see on the other video is I created a notebook that is going to be accessible to everyone as long as you want it. The link to the notebook will be in each YouTube video, and there's a password on it, but that will also be on the YouTube channel. So you can check back on these during 8th grade if you needed extra practice, or if this session was helpful and you're confused, you can always come back to this notebook and it'll be here. So the most important thing I wanted to start with was variables, because these will follow you forever. You're going to do linear equations with these. You're going to do Pythagorean theorem with these. If you do not know how to isolate a variable, math is going to be difficult. So we're going to start with variables. And what exactly is a variable? It is a letter that represents an unknown value. So if we're trying to, we don't know how old Ms. Humphreys is, Ms. Humphreys' age would be X. So it's an unknown value. X is the most common, but you can use any letter. It's the most common, but any letter will work. You'll see this when we get to Pythagorean. They use A, B, and C. You'll use this, you'll see this when we get to, linear functions. You'll have M, X, and B. There's all different kinds of variables that all stand for specific things. But if it's just unknown, X is always a great way to go. So there are two different things you can do with or a lot of different things you can do with variables. You can solve for the unknown, or you can group like terms. So I think the easiest way to start with is grouping, and then we'll go to two-sided and solving. So I did go ahead and pull up an example question here from my Google Classroom that I have made, which is on the other window. So let me go here. So you'll see our first problem that we're going to look at is this 3x minus 4 plus 6x plus 5. So if you'll give me 1 second, I am going to write on my screen. And it was 3x minus 4. 4 plus, we have 6x plus 5. Okay, so the very first thing I want to do when I get this equation, I want to read the instructions. What is it asking me to do? Well, I know it's not asking me to solve because there's no equals here. There's no equals anything. So I know it's not asking me to solve. But if I look, it also tells me combine like terms. So the first thing we want to do is define a like term. Well, these are numbers or sets of numbers that are similar. So if we look at this, the things that I see are similar are there's an x here, and there's an x here. Well, those are both a number with an x, so those are similar. The problem that we have when we approach this is the numbers, or excuse me, the symbols in front of the numbers. The symbol in front of the number goes with that number. So this 6x is positive. This 4 is negative. This 5 is positive. The number in front, or excuse me, the symbol in front of the number goes with it. It is not after, it is before. So this 6x is not positive. This positive 6x is adding to this positive 5. This positive 3x, because there's nothing here, so it's an assumed positive. This positive 3x is subtracting 4 from it. So the symbol before the number goes with the number, not after. So we have a negative 4 and a positive 5. Well, this is integers. The way I look at this is if I owe you $4 and I pay you back 5, how many dollars do you now have? 1. Integers. I always look at it as money. Negative is I owe you, positive is I've paid you back. So if I look at this negative 4 and this positive 5, I owe you 4, I've given you 5, I now have 1, or you now have 1 positive dollar. So that was that section. I'm done with those. So I have 1, and it's a positive 1. Now I have positive 3x's and positive 6x's. So all I'm doing in my mind is I'm taking 3 apples and 6 apples and I'm putting them together. That's it. So I'm going to end up with 9 of something unknown plus the 1 we already had, and I've combined my like terms. Let me wait 8 seconds to see if you guys have any questions there. Wait for a question to pop up in the chat if you have any. Isolate your terms that look the same. Make sure you have the right symbol with the right numbers, that 4 is negative, that 5 is positive. I love colors. I like to highlight those in green and those in blue. And then I've simplified my equation. So that is simplifying or combining like terms. Now, what do we do if there is A equals on the other side? What if we're asked to solve something? Okay, so let's try here. If I'm asked to solve an equation, and let's say I'm given 3x plus 5 is equal to, I'm never good at making these up off the top of my head, 8. Humphreys is not good at making these up, and also that's what my 8s look like. It's 2 circles stacked on top of each other. 8. That's an 8. Okay, so now we have a number attached to a variable. We have another number on the outside, and we have an equals. So we know it's asking to solve for that variable. It's really all I can do with this. There's no terms I can combine because there is nothing on the left that matches. And it's not asking me for distributive property. I'm not moving anything. I just have 3x plus 5 equals 8. So an example of this that you're going to find in your real life is that you only have $8 and it costs $5 for the Uber to come pick you up and $3 a mile. How many miles can you go? You have $8 to go to the concession stand. A hot dog costs $5 and a bottle of water costs $3. How many bottles of water can you buy? These are examples of these linear equations that you're going to see constantly where you only have to solve for one variable. So let's go ahead and solve for this. Now, I have the 3 and the x. The way I look at those two are that's the last thing I can touch. I want to move from the outside in. That 3 and that x are attached. They are combined. They are that obnoxious couple in the hallway that you can't get to move from your locker. You're going to have to move the people around them to get to your locker. So the first thing we need to do is move this little straggler that's hanging out over here. How we move, you always have to do to one side what you have to do to the other. So if I move that 5, what I'm trying to do is get rid of it. Well, how do I get rid of a positive 5? I take away 5. Does that make sense? That if I have 5 and I want to have 0, I have to take away 5. Well, what I do to one side, I have to do to the other. So I took away 5 here, I have to take away 5 there. It's a scale. We're balancing it so that it's always the same. Okay, so when I take away 5, make sure, this is where a lot of y'all get tripped up on the little things. When I take away that 5 and I exit out here, a lot of you will go add 5 down here. No, please don't do that. Do not add 5 there. You are subtracting on both sides. So make sure you're doing the exact same thing to the right that you did to the left, or vice versa. So 8 minus 5 equals 3. So now you're like, oh, 3, I'm done. No. There's a whole variable over here that we just left. So what we're left with now is 3x is equal to 3. Well, when you look at these variables, 3 and x are combined when two things are touching with no symbol in between. It's multiplication. Let me see if I can scroll down this page here and add some more notes. When a variable and a number are next to each other with no symbol, they are multiplication. Now, the inverse, or fancy science math word for opposite, inverse. The opposite function of multiplication is division. Okay, so if I am going to do the opposite, remember positive 5, the opposite was negative 5. I brought negative 5 over here. The opposite of multiplication is division. Or yes, division, pardon me. So what I'm going to do is divide by 3 over here and divide by 3 over here. A fraction is just division. It's asking you how many times does the bottom number go into the top number. 3 goes into 3 once. So I have 1x is equal to one of those x's. It's not a 0x, you're not zeroing anything out. 3 goes into 3 one time. So 1x is equal to some amount. So you should always have like an invisible 1. front of the x. You don't always have to write it because it's invisible. It's assumed. But if you have a variable that's just x, it's always one of those x's. Do the same thing on the other side. 3 goes into 3 one time. So 1x equals 1. I should be able to put this into any equation and it should work, right? I should be able to, as every time my x goes up, I have one of those x's is equal to 1. Does that make sense? Okay. So that's variables on one side. Work from your way out, in. Get rid of all the extra stuff that's in the way. The plus 5 is in the way of the 3x. Then get rid of the 3 and you're isolated down to the x. You're trying to move outward in. So those are examples on one-sided equations. I'm going to add another. I want you guys to do it on your own sheet of paper and drop your answer in the comments. It should just be like one thing. And make sure you comment it to me, not to everyone, or else they can see. So let me write out another equation. Give me 1 second to think one up because Ms. Humphreys was not prepared. Okay, your problem for yourself is 4 plus 9x equals 22. What does x equal? I will check back at 1:05. You have about 75 seconds to do 4 plus 9x equals 22. I'm just going to keep you private there and then mark those in the comments. 4 plus 9x equals 22. What does x equal? About 30 more seconds. Take your time. You guys are the only ones here. Wait for a chat notification. Remember to go from the outside in. All right, I'm gonna wait 30 more seconds and then I'm gonna do it because I don't have a chat. And I don't know if you guys are there, but I'll post it online, so it'll be fine. Okay, I'm gonna go ahead and see if I can get the screen lower. We can start solving. Okay, so step number 1 is to isolate the variable. If I see the variable x is attached to the 9, I know the 9 is the last thing I can get rid of. So I'm going to go with this outside guy here first. Well, we know that the sign in front of the 9 is positive, and there's nothing in front of the 4, so we have an assumed positive 4. Now we have 22 on the other side. So how do we get this 4 away from this 9? The opposite. So we're going to do the opposite of positive 4, which is negative 4. What I do to one side, I have to do to the other. So if I have $4 and I spend $4, I now have no dollars. And I bring down my 9x because I didn't do anything with him. What I did to one side, I had to do the other. So 22 minus 4 is equal to 18. So now my new equation is 9x equals 18. I am not done. It did not say simplify, it said solve. So 9 and x are smushed up together. We know that when a variable and a number are next to each other with no symbol, they are multiplication. The inverse of multiplication is division. So I'm going to divide, if I can get my thing to work. There we go. I'm going to divide each side by 9. Divide each side by 9. 9 goes into 9 one time. So 1x is equal to 9 goes into 18 2 times. So one of those x's is equal to 2. The way you'll see this written is x equals 2. There's an assumed, we pretend that that 1 is always there because what we're saying is one of those x's is worth the integer of 2. Okay. Now, I think the last concept I'm going to cover for today is what happens when there are variables on both sides of the equation. So what we've done so far is we have defined a variable. We've seen common examples of where we need variables for unknown numbers, such as how much we want to buy of something, how many miles we can go, etc. Something in my house is beeping. Okay, sounded like a bomb was about to go off in my house. We've discussed what variables are, common uses of them when we don't know a number, such as how many of something we need to order or what our budget will allow us to buy. We have talked about grouping, finding those similar groups. If those x's are attached, you're essentially saying that those are apples, the other variables are oranges, and you cannot add those together. You just have to combine like terms. We have solved for when there's a variable on one side. We've learned about inverse operations. What you do to one side, you have to do to the other. And we have practiced that independently. Now, the last thing I want to talk about is when there are variables on both sides. What happens when there's an x on either side and it's asking you to solve for the x. So if you'll give me 1 second, I'm going to find a good example of that. Ms. Humphreys is not great at making up her own questions. I'm a science teacher at the end of the day. And math has to actually work out. It's stupid. This is also my Google Classroom that I created last year for my math class in 8th grade. So if you ever get to the point in 8th grade where you're stressing out or you need practice or you need help, I actually have this entire Google Classroom created already. So we're on expressions and equations right here. This is everything I have for that. Combining like terms, equations on both sides. All of this is already here if you want more practice. So we're going to look at equations on both sides and we're going to solve for one of these. I think this looks nice. So we're going to do 4x plus 1 equals 5x minus 2. And also, you're always welcome to, if you want to do this extra practice and send me your answer key, I will either hand deliver or mail you a prize. Obviously, I know Takis are a favorite, but if you want something else, let me know. I am happy to reward you for working during the summer. I'm very proud of you. So here's some more example questions, but let's start with this one. 4x plus 1 equals 5x minus 2. We're going to move that over there, and I'm going to do 4x plus 1 equals 5x minus 2. All right, so what we're doing here is essentially combining the two things we've already learned. We have learned how to combine like terms, and we've learned how to solve for variables. Now we're just doing them together. So the first thing I'm going to do is highlight the variables that are the same. You know I love me some colors, so I'm going to take my green, and I see my 4x, and I see my 5x. Now, I also notice there are no symbols in front of those, which means they have to both be positive. Then my other like terms are 1 and 2, and negative 2, pardon me. If you notice, there's an equals in the middle. This means I cannot just add 4 and 5. There's an equals. There is some kind of, I'm on the left to the right. I'm on inverse and opposite reactions now. So let's look at how I can attack this. I have 4x on one side and 5x on the other. I always like to go with the side that has more because I think it's easier to work. It's easier to not create negative numbers for yourself. So let me show you both examples. You can do it either way. There are 1,000 ways to do math, which is the fun and stressful part of this. So let me show you the different ways we could work this out. Okay. I can move left to right, or I can move right to left. I'll start with the way I don't like. I can take 4x plus 1 equals 5x minus 2. And I can say, all right, I'm going to move this 5x over here. This is a positive 5, so I'm going to subtract 5. And what I do to one side, I have to do to the other. So I've done my like terms. I had $5, I spent 5. Well, 4 minus 5, if I have $4 and I spend 5, I now have negative $1. Bring down the other variables I still had. Okay, here's the problem that we're going to face now, is you can continue. Here's a common mistake that people make. You can say, okay, well, I have negative 1x plus 1 equals negative 2. Well, if I add 2 to each side, I can do what one side to the left? Negative x plus 3 equals, oh, nothing. That wasn't right. That doesn't help. I need to move variables to one side and integers to another. I need my x's on one side and I need my normal numbers on the other. So I'm going to erase all of this so when you look at the notes, it doesn't confuse you later, because none of that's what we wanted to do. I'm going to jump back to where we were correct, to 4 minus 5 is negative 1. X. Always remember to bring down your variable. That's a common mistake y'all make too. You just drop a variable and all of a sudden we have all real numbers. We don't know how we got here. Plus 1 is equal to negative 2. I need x's on one side, numbers on the other. So in order to get this positive 1, I have to do inverse, negative 1. Now I'm left with negative 1x is equal to negative 3. Because if I owe you $2 and I borrow another $1, I owe you 3. Now, here's where we're just going to add more steps of math where we could avoid later, and I'll show you how to avoid it later. Now we have negative 1x is equal to negative 3. That doesn't help you to have a negative variable. The absence of this is equal. No, too meta. Calm down. You want positive. So the way that we do this is negative 1 times x is multiplication. Divide by negative 1. And we know that negative 1 goes into negative 1 one time. And we know that negative 1 goes into negative 3 3 times. Because a negative divided by a negative is a positive. So our answer, when we went from right to left, moved the right over to the left, was positive 3. Now I can show you that no matter which way I go, I can get positive 3. So let me scooch this over here. Do the exact same problem right next to it to show you. No, I want to go right. Pay attention to me. Thank you. All right, so I'm going to do the exact same problem right next to it to prove to you, homie, if you do not listen, thank you. To prove to you, you can go either way. So let's do one more time. 4x plus 1 equals 5x minus 2. Last time we moved that 5. This time we're going to move the 4. So I am going to subtract 4x. This time I'm going to put my variable on the right and my number on the left to prove to you that it does not matter which way you go. So we have 4x plus 1 equals 5x minus 2. I'm going to move the 4x this time. What I do to the left, I have to do to the right. If I have $4 and I spend 4, I have no dollars. Remember to still bring down your remaining numbers. We have a positive 1 is equal to 5 minus 4 is 1x. Bring down your other variable, minus 2. All right, now remember, we are not moving that 1 over here. We're moving the 2 over here. The inverse of a negative is a positive, so we're going to add 2 to each side. And then I'm going to be left with negative 2 plus 2 is 0. 2 plus 1 is 3. 3 is equal to 1x. And notice they're both positive. So x is equal to 3. Notice I didn't have to divide by a negative. I didn't have to worry about negatives. I kind of got to stay in a cleaner area. So if you subtract the smaller variable from the larger, you'll usually end up with less steps because you won't have to divide by the negative. All right. So that is a walkthrough of how to do when variables are on both sides. I'm going to add one practice problem and then we are going to be done for the day. I will also post, oh my gosh, my phone's so popular. I will also be posting again the link to this note so you can keep this, and I will post in these notes the example problems that you see here so you can practice these. If you email me or send me a picture on Remind of these completed, I will happily mail you a prize just as soon as you tell me what you want. Let me find a good, oh, let me not post it with the answer key. Good job, Ms. H. All right, let's try this one. 4x minus 1, negative x plus 9. This will be y'all's practice, and then we are done for the day. These really are supposed to only be like 20, 30-minute little short tutorials. I don't want you to just stay doing summer school all the time. I mean, I do, obviously, but. Okay, 4x minus 1 4x minus 1 equals negative x plus 9 equals negative x plus 9. All right, this is the problem you guys are doing independently right now. If you're watching the video, please pause to complete the activity. If you are live, drop your answers in the chat. 4x minus 1 equals negative x plus 9. Negative x plus 9. All right. Hopefully you guys have paused the YouTube video or written this down in your own notes. We are going to just start from the baseline of the tips I told you to start with, and then we are going to move on. So let me get this as the full screen. So we're going to find our common or our like terms. We have 4x and negative x. Remember, the symbol in front of the number goes with it. Then my other real numbers, I have negative 1 and 9. So remember, my first tip was to always move the lesser of the variables. So which number is smaller, 4 or negative 1? Feel like Dora the Explorer. Good job, negative 1. So I'm going to move the negative 1 to the left rather than moving that 4. So my options are I can subtract 4 from each side, or hold on, I can subtract 4 from each side, or I can add 1 to each side. And I personally think it's easier to add 1 than to take away 4. So if I owe you $1 and I pay you back $1, I owe you nothing. Remember to always bring down our other variables. Always bring down your equal sign. Then if I had $4 and I gave you 1, I now have $5. Okay. Remember, we cannot move this 9 to the left. We have to move this 1 to the right, because you can't have everything on one side of the equals. It doesn't equal anything. You need variables on one side, numbers on the other. So my only option is to move this negative 1, and the opposite of a negative is a positive. What I do to one side, I have to do to the other. So I'm going to be left now with, and of course I'm not going to scroll down. There we go. If I owe you $1, I pay you back $1, I owe you nothing. Bring down the variables, bring down our equals. 9 plus 1 is 10. You are not done. 5x does not equal 10. I don't want to know what 5x equals. I want to know what x equals. So remember, when two things are shoved up against each other, they are multiplication. Inverse of multiplication is division. Divide each side by 5. 5 goes into 5 one time. So one of those x's is equal to 5 goes into 10 2 times. And remember, you'll most likely see the answer is x equals 2, because there's that implied 1. So your final answer for that was x equals 2. Let me erase that so it doesn't look like 21. X equals 2 is your final answer for that equation with variables on both sides. All right, that concludes variables. One more time as summation. We have defined a variable, seen the situations in which we need them, talked about combining the like terms, inverse operations with variables on one side, and operations with variables on both sides. So this is a review. This is all 7th grade. You should absolutely know how to do this going into 8th grade. Once you get into 8th grade, you're going to start doing linear functions, y equals mx plus b, and a little bit of Pythagorean theorem that you saw in 7th grade, where a squared plus b squared equals c squared. So these are very common. You have to know variables. So that concludes variables for the day. Again, this is being recorded and will be immediately posted on the YouTube after. If you have any questions, please email me or drop them in the chat. And as always, I am here if you need me.